Hello students, welcome all of you in online learning of microprocessors and microcontroller subject. In this lecture, we are going to study the pin diagram of 8085 microprocessor and addressing modes of 8085 microprocessor. My name is Pooja Subhashrao Deshmukh from International Center of Excellence in Engineering and Management College, Aurangabad. So, in this lecture, we will study the pin configurations of 8085 and addressing modes of 8085. In addressing modes, there are 5 types of addressing modes, that is immediate addressing mode, register addressing mode, direct addressing mode, register indirect addressing mode, and implied or implicit addressing mode. Now, let's get started. In last lecture, we will see the architecture of 8085 with its architectural block diagram and what are the functions of the 8085 microprocessor with its every block's function with details. Now, in today's lecture, we will see pin diagram of 8085. You can see that here the pin diagram of 8085 having two sides. In LHS side there are 20 pins and in RHS side there are 21 to 40 pins. In LHS side the pin number 1 is X1, pin number 2 is X2, pin number 3 is reset out, pin number 4 is SOD and pin number 5 is SID, pin number 6 is trap, pin number 7, 8, 9 is RST reset 7.5, 6.5 and 5.5. Then 10 and 11 are INTR and INTA. Pin number 12 to 19 that is AD0 to AD7 and pin number 20 is VSS. Then in RHS side, pin number 21 to pin number 28 is A8 to A15. Pin number 29 is S0. Pin number 30 and 31 is WR bar and RD bar. Then pin number 32 is VPP. Pin number 33 is S1. Then pin number 34 is input output or M bar. Then 35 is ready. 36 is reset in, 37 is clock out, 38 is HLDA and 39 is hold or 40 and the last one is VCC. Now we will see the detailed function of these pins one by one. First one is address bus, that is A15 to A8, that is it carries the most significant 8 bits of memory input output addresses. Then data bus is AD0 to AD7, that is it carries the least significant 8 bit address and database. Then control and status signals. These signals are used to identify the nature of operation. There are 3 control signals and 3 status signals. 3 control signals are RD, WR and ALE. RD is used for indicate the selected input output or memory device is to be read and ready for accepting data available on the data bus. The next one is WR. This signal indicates that the data on the data bus is to be written into selected memory or input output location. Then ALE is positive going pulse generated when a new operation is started by the microprocessor. When the pulse goes high, it indicates address, and when pulse goes down, it indicates data. Also, 3 status signals are IO by M, S0 and S1. Then IO signal is used to differentiate between input output and memory operations. That means when it is high indicates input output operation, and when it is low it indicates memory operation. Then S1 and S0. These signals are used to identify the type of current operation. Then next one is the power supply. There are two power supply signals. One is VCC and another one is VSS. VCC indicates the positive 5 volt power supply and VSS indicates ground signal. Then next one is clock signal. There are three clock signals, that is X1, X2 and clock out. X1 and X2 is a crystal, that is RC, LC and network is connected at these two pins, and it is used to set the frequency of the internal clock generator. This frequency is internally divided by 2. Then another clock signal is clock out. This signal is used as a system clock for devices connected with the microprocessor. Interrupts and externally initiated signals. Interrupts are the signals which is generated by the external devices to request the microprocessor to perform a task. Then there are 5 interrupt signals, that is TRAP, TRAP, RST 7.7, 7.5, RST 7.6.5 and RST 5.5 and INTR. We will discuss the interrupts in detail, that is one by one. First one is INTA. It is an interrupt acknowledgement signal. Then reset in. This signal is used to reset the microprocessor by setting the program counter to 0. The next pin is reset out. This signal is used to reset all the connected devices when the microprocessor is reset. The next one is ready. This signal indicates that the device is ready to send or receive data. If ready is low, then the CPU has to wait for ready to go to high. The next one is hold. Hold is, this signal indicates that the another master is requesting the use of the address and data buses. The next one is HLDA, that means hold acknowledgement. It indicates that the CPU has received the hold request and it will relinquish the bus in the next clock cycle. HLDA is set to low after the hold signal is removed. Then another one is serial input output signals. There are two serial signals, that is SID and SOD. These signals are used for the serial communication. SOD is serial output data line. SOD means serial output data line. The output of SOD is set or reset as specified by the SIM instructions. Then next one is SID. SID is a serial input data line. SID means the data on this line is loaded into accumulator when the RIM instruction is executed. Here we will understand what are the functions of every pin. Now we will see next topic, that is addressing modes of microprocessor 8085. There are 5 types. First one is direct addressing mode, second one is register addressing mode, third one is register indirect addressing mode, and fourth one is immediate addressing mode, and fifth one is implied addressing mode. Now we will see one by one in detail. First one is direct addressing mode. In this addressing mode, source and destination could be a register or RAM location, but both cannot be same. Either the source has to be register followed by RAM location or destination, and vice versa. For example, the address of the operand is specified in instruction itself. Internal RAM addresses starting from the 00H to 7FH, and special function register addresses starting from 80H to FFH are only allowed in the direct addressing mode. We will take an example. For example, move R3 70H means the contents of RAM location 70H are copied to the register R3. Next one is move 32H comma A means the contents of accumulator A are copied to RAM location 32H. Then next one is register addressing mode. In this register addressing mode, the source and the destination both are registers and must be same size, as in difference in size we will give errors. The data is specified in the registers for various operations as per given instructions. Only accumulator A and R0 to R7 registers of each memory bank are allowed in this mode for transfer of the data. The data transfer can take place between Rn means R0 to R7 registers and the accumulator A only, and cannot be done between Rn registers. Now we will understand by the example. Suppose move A comma R3 is the example, then the contents of register R3 are copied to accumulator A. Then another example is add A comma R4 means the contents of register R4 are added with the contents of the accumulator A, and the result is stored in the accumulator A. The next one is move dptr comma A means this instruction will be end up giving error as a there is size in difference, that is dptr is equals to 16 bits and A is equals to 8 bits. The next another one is immediate addressing mode. In this addressing mode, the data is directly specified in the instruction itself. The source is the immediate data and the destination of this instruction could be any register. That means hashtag is a symbol which specifies that the operand is an immediate data on which operations to be performed, and the result will be stored in the destination register. Now we will see by an example. For example, move A comma hash 65H means the digit 65H is copied to the accumulator A. Another example is move dptr comma hashtag 1615H means a 16-bit digit 1615H is copied to data pointer which is 16 bits. Next one is indirect addressing mode. In this mode, the address of the operand is specified in the register. Only the registers R0 and R1 are data pointers, that is the data is stored on the RAM location whose address is held by either R0 or R1. It can only use addresses from 00H to 7FH, or @ sign is used in the instruction set and is placed before the registers R0 and R1 to make the two registers as a pointers. Now we will see by an example. Move A comma @R0 means the contents of the memory location is held by R0 which is copied to accumulator A. Another example is move R0, A means the contents of the accumulator A is copied to memory location held by R0. Then another example is move X A@dptr means the contents of the external RAM location which is held by dptr, that is 16 bit, are copied to the accumulator A. The next example is move X A,@R0. The contents of the external RAM location is held by register R0 is 8 bit, are copied to the accumulator A. Then the last one is indexed addressing mode. In this addressing mode, the address is indirectly specified in a accumulator, data pointer dptr and program counter. It is usually the sum of the addresses which is stored at A plus dptr or A plus PC means program counter. This addressing mode is very useful because the ROM contains permanent data which is stored in the form of lookup tables. Then to access the lookup, the addresses are given is as a sum of contents of two registers, where one acts as a base and another acts as a index within the table. Also, this mode is used for the access data from the code memory and the denoted by C in the instruction. Let's see with the example. For example, move C A,@A plus dptr means what? Contents of the ROM location pointed by the sum of addresses A and dptr which is 16 bits are copied to accumulator. In this case, the data pointer holds the base address and the accumulator which is 8 bit holds the index or displacement. Here we will study all the addressing modes of 8085. Here our first unit of microprocessors and microcontroller subject is finished. From next lecture we will start second unit which is 8085 instruction set and programming. Till now, thank you very much.